Alright, so today we'll be doing questions 5 through 7 of the Adhesive AP Computer Science Diagnostic exam. And starting with question 5 here, when designing a class hierarchy, which of the following is not true about the parent class? And we see here that the answer is B. The parent's class variables should be made public so the child class can access them. Now, this is not true because when a variable is made public, any class can have access to them. And this is specifically saying so that the parent and the child can access them. So um, while public is available to any class, the protected variables and methods would only be accessible by the parent and the child class. And you also have private, where it would be exclusive to the parent class, but the best for this would definitely be protected and not public. Now let's say you didn't see this the first time. I sure know I didn't when I took this. And you could look at the others, and starting with question E over here, it is true because the super keyword is mainly used for taking variables from a parent class's constructor. So the child class would be able to access the parent class's methods and the parent's constructor with this super keyword. And on to answer D, it would be true because with the parent class, you have, let's say with this diagram I kind of threw together, P would be the parent class, and this would be all the methods and variables that the parent class would have, and the child class is within the parent. They're passed they're passing on all of these methods. All of these methods and variables are available to the child class. However, the child class can have its own variables and methods, but the parent class cannot access these. So this would be true that the parent class cannot access any of the methods within the child classes. And this could be taken the same way as answer A over here, because the parent class should hold any variables and methods common to all the child classes. Yes, they should, because as stated earlier, the parent class has all of its variables and methods, but the child class has free access to those and not the other way around. So A would be true as well. And C would also be true, where it is possible for a parent class to have a parent class itself, because, well, that is the very concept of a class hierarchy. So, and down to question 6 over here. What is the minimum number of times yo will be printed? And with this code that's presented here, we have a recursive for loop that will take integer x, and you could really put any number in here and try it, but and then it will print yo that many amount of times. And the minimum number of times yo will be printed, you can find in this part of the code right here, where x is a random number, but such that x is greater than or equal to 1. So the minimum that x could be is 1, and x will control the number of i's and the number of j's in these for loops, leaving the minimum number of times to be 1. And so we have the minimum number. As for the maximum number, and number 7 over here, as I said before, this is a recursive for loop. Now, we can't have 1 be the maximum because it's greater than or equals to 1, so it's probably going to be able to go much further. Even though we can't say what n is here for sure, there are 2 for loops, and you can plug in any number other than 1, and it would definitely print yo more times, and it would not just print it 2 times, because with recursive statements like this, you have like an exponential growth in the number of times, because it would be going through this for loop, then that for loop inside of that for loop for every time the first for loop activates. So it would not be 2 simply because these are not if statements. I wish I had a better way to word that, but with if statements, it would only be doing them once for each, or not if statements, but basically for every time that it would print it out in a recursive statement, it would almost multiply that number of times, and you see down here, the option n squared would best fit a recursive loop.